have a circle, and inside it is a path made from 3 straight line segments. The bottom horizontal segment, AB, is a chord of the circle, and its length is exactly 4 units. From point B, a vertical segment goes straight upward to point C, with a length of 6 units. Then, from point C, a horizontal segment extends to the right until it reaches the circle at point D. That segment, CD, is exactly 2 units long. Our mission is to find the exact radius of the circle. Let's begin with the chord AB. There is a famous theorem in circle geometry. A radius that is perpendicular to a chord always bisects that chord. So if we draw the vertical center line through the center of the circle, O, it cuts chord AB exactly in half. Since AB is 4 units long, each half must be 2 units. That means point B is exactly 2 units to the right of the center line. Now look at point C. Since C lies directly above B, it is also 2 units to the right of the center line. From C, we move another 2 units to the right to reach point D. So point D is 4 units to the right of the center line. Now comes the key idea. Let's extend the horizontal segment through C and D all the way across the circle to the left. Suppose it meets the circle again at a new point M. We have now created a full horizontal chord. Since the center line bisects every horizontal chord, the portion on the left side must match the portion on the right side. The right half measures 4 units, so the left half also measures 4 units. Next, extend the vertical segment BC upward until it meets the circle at a new point N. Now we have a vertical chord and a horizontal chord intersecting at point C. Whenever 2 chords intersect inside a circle, we can use the intersecting chords theorem. It says 1 segment times the other segment on the first chord equals 1 segment times the other segment on the second chord. Applying the theorem at point C gives BC multiplied by CN equals DC multiplied by CM. Substitute the known values. BC is 6, DC is 2, and CM is the entire left portion of the horizontal chord, which is 6 units. So we get 6 times CN equals 2 times 6. The 6's completely cancel out, and we get CN equals 2. Now comes a beautiful circle theorem. Look at angle ABN. It is a right angle. An inscribed angle of 90 degrees always subtends a diameter. Therefore, AN must be a diameter of the circle. And since every diameter passes through the center, AN is exactly twice the radius. AN equals 2R. Now, focus on triangle ABN. It is a right triangle. Its base, AB, is 4. Its height, BN, is 6 plus 2, which is 8. And its hypotenuse, AN, is 2R. Time for the Pythagorean theorem. 4 squared plus 8 squared equals the quantity 2R all squared. 4 squared is 16. 8 squared is 64. And 16 plus 64 is 80. So 80 equals 4R squared. divide both sides by 4, and we get 20 equals r squared. Take the square root of both sides, and we find r equals the square root of 20. The square root of 20 simplifies to 2 times the square root of 5. So the exact radius of the circle is 2 times the square root of 5 units. And if you'd like a decimal approximation, that's about 4.47 units. Let me know in the comments if you figured it out before the end, and I'll see you in the next one.